Hello everyone. Today I will go over the problem on dimension and Buckingham-Pi theorem. Let's read the problem statement first. The power required by an agitator in a tank is a function of the following variables. A. Diameter of the agitator. B. Number of rotations of the impeller per unit time. C. Viscosity of liquid. D. Density of liquid. First part of the problem is asking to find the relationship between power and four variables by using Buckingham-Pi theorem. And for second part of the problem, it's about ratio of power if the diameter is doubled based on the relationship from the experiment. So, before solving the problem, I will go over each variable and check their dimension. We're gonna use three basic dimensions throughout the problem, which are m for mass, l for length, and t for time. So the first variable is power. Based on the definition of power, it's energy per unit time. We can also write these equations as force times distance over time, because energy is force times distance. We know that force is equals to mass times acceleration. We can write these equations with dimension of m times l times t to the negative 2 times l for distance over time. If we simplify this equation, it's m l squared t to the negative 3. For second variable, it's diameter, which is simply length. And for number of rotations of the impeller per unit time, we can say it's n, and then number of rotation per time. Since number of rotation is dimensionless, we can simply write the dimension of this variable as t to the negative 1. For finding the dimension of viscosity, we need to know the equations of shear stress, because shear stress is equals to viscosity times partial derivative of velocity profile by the length. Since we know that shear stress is shear force per area, so we can write its dimension as mlt to the negative 2 over area, which is L squared. We can simplify these equations as ml to the negative 1 times t to the negative 2. We can also write the dimensions of partial derivative of velocity profile. Velocity is L times t to the negative 1, and z refers to the length, so we can simply write this equation as t to the negative 1. Now we can find the dimension of viscosity, because we can set the equation as dimension of shear stress is equals to dimension of viscosity times dimensions of partial derivative of velocity profile by length. It's end up having the dimension of viscosity is equals to m times L to the negative 1 times T to the negative 3. And for last variable, density of liquid, the density is mass per volume, which ends up having m over L cubed, which is m times L to the negative 3. So these are dimensions that we need to know to solve the problem. Now we have dimensions for each variable we need. For using Buckingham pi theorem, we can find the number of pi group by subtracting total number of variables by number of basic dimensions m, L, and t. In this case, it will be 5 minus 3, which is 2 pi group. We will assume that rho, d, and n are repeating variables. For the first pi group, we can write down as power times repeating variables. We will use this multiplication into dimensions, and this multiplications of dimension should be dimensionless, which is m to the 0 times L to the 0 times T to the 0. We can split it off this multiplications into each terms, m terms, L terms, and T terms. And the exponent of each term should be equal to 0. From this calculation, I end up having a, which is the exponent of rho, is equals to negative 1. Exponents of dimension should be equals to negative 5, and exponents of n should be equals to negative 3. So the first pi terms can be written as p times rho to the negative 1 times d to the negative 5 times n to the negative 3. We will do the same thing for the second pi group. For the second pi group, we will multiply repeating variables with viscosity. Again, the multiplication of dimensions should be dimensionless, so m to the 0 times L to the 0 times T to the 0. I did exactly the same thing for this part. I splitted these multiplications into each term and make the exponent of each term is equal to 0. So the second pi group ends up having viscosity mu times rho to the negative 1 times d to the negative 2 times n to the negative 1. Now we have two pi terms, so we can move on to the second part of the problem. From what we found for each pi group, we can write the equation as pi 1 is equals to k times pi 2 to the n, where k is dimensionless constant. We can substitute each pi group to these equations and ends up having p times rho to the negative 1 times d to the negative 5 times n to the negative 3 is equals to k times mu times rho to the negative 1 times d to the negative 2 times n to the negative 1 to the n. Now we can use the given condition, which is the power consumption is found experimentally to be proportional to the square of the speed of rotation. So power is proportional to the square of the speed of rotation, n squared. We will use p and n terms from the above equation. So we will have p times n to the third is equals to n to the negative n. If we calculate the equation, we can have the n value, which is 1. From this n value, we can rewrite the equation as p times rho to the negative 1 times d to the negative 5 times n to the negative 3 is equals to k times mu times rho to the negative 1 times d to the negative 2 times n to the negative 1. We can simplify these equations in terms of p, so we can have p is equals to k times mu times d to the 3 times n to the square. To find the answer for the problem, we need to find p2 over p1, where dimension is doubled, so we can write down 2d1 is equals to d2. We can also assume that mu, n, and k are constant. So we can write down each p terms with the above equation. So p1 is equals to k times mu times d1 cubed times n squared. We can write the same equation for p2 as well, and we can substitute d2 is equals to 2 times d1. So to find p2 over p1, we can rewrite the equation like this. And since they are all constant, they can be cancelled out and having 8. So we can conclude that the answer for the second part of the problem is power will be increased 8 times. So that's it for the problem, and thank you for watching.